Hello, everyone. Welcome back. We've got our next speaker. Very interesting topic. Professor Emeritus Richard Silberstein. He holds the title of Professor Emeritus at Swinburne University of Technology. He's the founder and chief scientist of Neuro-Insight, Pty, a consumer neuroscience company operating in Melbourne, London and New York. Richard holds a PhD in neuroscience from the University of Melbourne and a Bachelor of Science with honours majoring in physics from Monash University. He has over 35 years of neuroscience research experience and is the originator of the steady state topography, SST, brain imaging methodology. He has authored and co-authored numerous publications in various areas of cognitive and clinical neuroscience, as well as consumer neuroscience. His most recent publications address the topic of brain functional connectivity, correlates of creativity and originality. My pleasure to introduce to you Professor Richard Silberstein, and he'll be talking about twins, telepathy, and the brain.
Let me just make some brief comments. First of all, in keeping with the theme of smorgasbord that you use, I'm just wondering where my talk is as part of the smorgasbord. I mean, generally a smorgasbord is a table full of edible delights, you know, sort of really tasty sandwiches, sweets, and nice edibles. I got a feeling my talk is going to be a bit like the vegetables your parents tell you have to eat because they're good for you. You know, a little bit boring by comparison with the other sort of amazing talks and really interesting stuff, you know, sort of the remote viewing, for example, of David Morehouse, astral projection, phone calls from the dead. I mean, it's really hard to compete with that. So bear with me, please. I'll keep this short and sweet and hopefully interesting. I should just mention also very briefly a little bit about myself. I've been interested in parapsychology since about the age of 14 or 15, considerably older than that now. And in fact, when I finished my physics degree, I decided I wanted to do research in parapsychology. And that was the reason I ended up doing a master's, which became a PhD in neuroscience, because I felt if I was going to do that, I really do need to understand a bit about the body and the brain, etc. What I discovered in doing my PhD was that if you want a career in academia, the best way of committing academic suicide was to say, I want to work in parapsychology. And so I've had to park my interest in that area and literally go on and do other things which are interesting in the neurosciences. But since I've retired, I now have the freedom to come back to, if you will, my first love, my first research love, which is parapsychology, but a combination of parapsychology and neuroscience. So in a sense, what I'm going to describe is the first experiment, essentially a pilot study that we've embarked upon, which is going to be part of a much larger research program combining neuroscience and parapsychology. So the first one will be the results. There'll be some speculations about what does it mean. And then if there's time, I'm happy to open it up for questions. So what I'm going to do now is share my screen and hope that it works. That's the title. I presented a version of this talk at the Science of Consciousness conference held in Sicily in late May, just a few weeks ago. It was well received in the session that I was presenting it. Let me start off with something that came up, that one of the parents of the people who were involved in the study, because we worked with twins. They were all female twins, it turns out, who were identical. That is to say, monozygotic. They both emerged from the same fertilized ovum. And one particular set of twins, relatively young, their mother was there as part of, basically because she was the adult. And she told us an interesting story about these twins who seemed to have this amazing link between them, where if something happened to one, particularly unpleasant, the other one would seem to know about it and feel it at the same time. And the particular example she gave is sort of indicated by that illustration of somebody on a netball court in pain, because in fact, it was something that had happened a few weeks previous to the time that these twins were involved in the study. And it was that they were both playing netball, and in fact, they were training. They were in a training session for netball. Now, what had happened was they were, in fact, put into separate teams. And in the training area, it was a very large training area, they were each training in quite different courts that were not in view of each other, separate rooms, etc. Now, what happened was, in one of the courts, one of the twins fell awkwardly and dislocated her knee. Now, what was fascinating was that even though the other twin could not see this at all, instantly she started limping at the same time. Now, when the coach was able to, in fact, apply a maneuver which essentially fixed that, relocated the knee, at that very point in time, the twin that had been hobbling and felt pain in a knee for no known reason, suddenly the knee felt good again. Now, that's just one example of sort of a constant series of stories that we've been hearing, particularly about identical twins. There's been lots of research, quite fascinating research. You know, the book by Playfair on twin telepathy, I think, covers quite a lot of it. In most cases, it's a difficult area to work in because quite often it's hard to recruit the twins and it's hard to actually get things to replicate because it's human nature, so to speak. And there have been attempts which have been published in the scientific literature. Generally, they've been along the lines of, let's put the twins in separate rooms, have one of the twins experience something, see a picture, put their hand in cold water, and then see what happens to the other twin in another room, you know, measuring what's called galvanic skin response, which is like light detection or maybe brainwave activity, as this particular paper does. So the basic idea is what happens in one twin when something occurs to another twin and they're not in view of each other, they can't communicate. So that's the basic idea behind it. And the area has sort of mixed. There've been some studies, they're hard to replicate. What we decided to do was to use a new methodology that we had invented in my laboratory. It was a method of measuring brain activity, but also measuring the communication between different areas of the same brain, what's known as functional connectivity. I just want to spend a little bit of time talking about functional connectivity. Now, this diagram is really just for illustrative purposes. The point is this: the brain doesn't operate by one little part of the brain doing something and then another part of the brain doing something. We now understand that the brain operates as a network, and essentially that network is a communication between different nodes, and which is made, and then when it's no longer required, it's broken. And both making those connections and breaking those connections are equally important. Now, the way the brain sets up these rapid communications, because the nerves are always there, but sometimes that communication is used, sometimes it's not. The way that the brain, different parts of the brain communicate with each other is they're oscillating. And when two regions of the brain talk to each other, they oscillate at the same frequency and they're in phase. So they're both oscillating exactly together. And when that happens, we know that those two regions are talking to each other. When they need to stop talking to each other, they're no longer operating at the same frequency. They're now out of phase. And as I said, it's just as important to be able to stop communication between regions that are no longer required as it is to create communication. And what I'll be looking at will be the first study anywhere in the world that looks at functional connectivity as a correlate of this sort of telepathic interaction. Is there a change in the brain functional connectivity in one twin when another twin is looking at, as you'll see, pictures? So let's have a look at, we used social media to recruit twins. It turned out that all of them were female. One of the important things that we did was we restricted the people going into the study to those who believed they had experienced what you could call, this telepathy, or the more neutral term these days is anomalous experience. It's got less baggage than the word telepathy. Anyway, so in a sense, we were recruiting rather specific individuals. Okay, now, I don't know if you can actually see that, but there were basically 5 pairs, 10 people altogether, all female. Their ages ranged from 13 to 39. We did these studies twice. We had them coming back. So the first series were done in November in 2022, and then we had them come back end of January, February, for basically a repeat with a slight addition, just to see how things replicated. So the basic idea, and I don't know if you can sort of see the two diagrams, but basically the idea is this. You've got one that we'll call a sender, because both of them take turns, and we'll call one the receiver. I don't believe it's sender and receiver, to be frank. I don't think something comes out of the sender's brain and goes to the receiver's brain, but let's just use that term. And basically what you've got is the so-called sender looking at a series of pictures, 100 pictures altogether, and 50 of those pictures are just pictures of general scenery, stuff that we got off Google Images, etc. The other 50 images are images that we asked them to provide us. We asked them to provide us with images that were relevant to them, things that were special, birthday parties, holidays with the parents, etc. In other words, things that were of personal relevance just to them. And we had these images, and one more or less saw these images coming up relatively randomly, and the other one just looked at a static screen, nothing happening at all. So our scientific hypothesis was this. When we look at the receiver's brain activity, the connectivity, and if we synchronize our analysis for the receiver for the points in time when the sender is seeing the images, which theoretically they're in another room, so it shouldn't have any effect, we should see statistically significant changes in the receiver that you only see when you synchronize it with the sender. So that was the basic, essentially, test of, are we seeing this evidence of telepathy, but telepathy looking at within the brain. So what was the arrangement? We had, this was the suite, the company provided the premises. So we had essentially 2 rooms. We had one twin located in one room, another twin located in another room. Part of the technology involves using a synchronous oscillating flicker in the visual pathways. It's the technology that we invented. It's been published for the last 30 years. We've published extensively in the cognitive neuroscience literature, clinical neuroscience literature, high impact journals. It's an accepted methodology. And when both of them took turns at being sender and receiver. And what I'm going to show you is the scenery of the ocean. That's just as an example of a general image. And the dog is an example of, a personal image. So when you see those, one's general image, one's personal images. Now, and they come up basically for 11 minutes. We have an image, and then we have a random period of time, and then another image, and then a random period of time, and then another image, etc. And the important thing is that there are random intervals between them. So you've got to get the timing right. Now, what we then do is we line up all the 1 second periods where the image occurs, and we do the analysis synchronized on that. I apologize, this is a bit more technical than you're probably used to, but it's an important part of the methodology, so please bear with me. Okay, so what does the data look like? And, relax, it should be okay. So here's an example of, for example, you're looking at the brain from the top down. I hope you can see my cursor. There are basically 20 dots on the brain. There's a nose, left ear, right ear, etc. So you're looking at the head sort of looking top down, and there are 20 dots there. These are 20 electrodes. These are the 20 contacts over the head. And when you've got 20 contacts, the number of unique combinations that you can have is 190. Take my word for it, it is. And so what I'm showing you here is, for example, 2 electrodes, 2 locations. There's one here on the left parietal region, and then there's another one in the midline up here in the frontal cortex. So this is a person looking at the image. You expect to see changes when you're looking at images and you're synchronizing things. And in this particular case, there's the 5-second interval, and between seconds 2 and 3 is when the image comes up on the screen. All the rest of the time, it's just a blank. And what you see is an increase in this connectivity. Don't worry about this number. From the maximum connectivity is 1, the minimum is 0. So you've got a maximum sitting up here, and there's a sort of a minimum sitting around here. Now, take my word for this, please, but we've developed statistical methodology to say, is that increase in connectivity around the time that the person saw the picture, is that statistically significant? And by statistically significant, what I mean is, what are the chances of seeing that just as a fluke if there was nothing there at all? Now, what you want is you want to make the probability of seeing that if there's nothing happening, the so-called null hypothesis, as small as possible. In psychology and others, if you're likely to see it less than 1 in 20 times, that's called statistical significance. I think that's pretty rough, to be frank, and I think we prefer something more rigorous. If you're likely to see that only about 1 in 100 times, we'll call that significant. So that's the 1% significance level. So that peak here, is that likely to be significant at the 1% level? This trough, is that likely to be significant? Because remember, both peaks and troughs are equally important. And we developed a statistical methodology, which I've used previously in other studies. And you can identify the points where the connectivity goes up beyond its baseline level or goes down significantly below its baseline level. So we can identify the peaks and the troughs of this connectivity. And what we then do is we say, all right, at any point in time, how many electrodes, how many communications are higher than you would expect or lower than you would expect? And that you end up with something that looks as messy as, I apologize, like this. Now, I hope you can see the bottom part of that graph, because basically what you've got is, let me concentrate first of all on the graph in the middle. So you've got 5 seconds. This is what a person looking at the screen, this is the sender, looking at the screen, looking at personal images. Now, the red line is the number of electrode pairs, the maximum is 190, which increased. And beyond a certain level, beyond about 20, that becomes statistically significant. The blue line is the number of electrode pairs where the communication decreased. That's just as important. And in this case, the number over 60 of those electrode pairs, and this occurred just before the image came up. There was an anticipation effect. Now, the maps you can see on the left and the right are, where are these communications? And what you see is in the lead up to seeing the picture, there's a huge reduction in communication in the frontal region. But when the pictures come up, there is an increase in communication, particularly involving the back of the head, involving the visual cortex. Okay, nothing remarkable about that. You are looking at essentially the brain of the person looking at the image. You expect to see that. You don't expect to see that if you're looking at the brain activity of the receiver. That's just looking at a blank screen. There's nothing to synchronize with. So just giving an overall thing. So we had 10 participants, 5 twins, 5 sets of twins, 10 people, and we got a result for personal images and general images. So each person produced 2 results. If there are 10 people, that produces 20 results. If they do the experiment twice, that would have been 40 results altogether. Unfortunately, there was an equipment failure, so we only got, instead of 40, 38 results. So that's what I'll be talking about. So here's an example. In 26 of those 38 results, we got nothing significant. And on the left, for example, this is twin 3-1. The red line didn't go above certainly 20 or anything, and in fact, it was not significant. The highest level of significance was 7%, which is worse than 5%, etc. The dotted line is also a control study where both twins were looking at a blank screen. There shouldn't be anything at all, and sure enough, there isn't anything. So basically, we saw nothing in about 26 of the 38 results. Okay. Most skeptics would say, yeah, what do you expect? That's what the results are. However, in 12 of the 38 cases, we got some very interesting results. Here's an example of one of them, one of our really good participants. Now, this is the pattern of brain activity of a person looking at a blank screen in another room, and you only see it when you synchronize the analysis to what the sender in the other room is looking at. If you synchronize it to anything else, you see zilch, and you get this increase here. Now, it only occurred, and by the way, that increase from the back of the brain to about the middle, that suggests some sort of visual processing. However, when we asked the person who was the receiver at the time, did you have any pictures coming into your head or anything? She said, no, nothing conscious. And yet the brain measure was saying, hey, something's occurring and it's related to visual imagery. Now, when her sister was looking at the special images, which I would have thought should have got a bigger effect, what we actually got was zilch. In fact, it was specific to the general images. Now, why? I'm guessing now. My guess is the general images were novel. They hadn't seen them before. They were interesting, and I suspect that's probably what's happening. Okay, how replicable is this? So that same set of twins, they came back 2 months later. So this is the same twin in November, looking at that activity, visual area lit up. And this is the same twin who came back in February. Now, I don't know if you can see it, but basically it's also statistically significant, but now her brain is responding more when her sister's looking at the special images, the personal images. So, why? I don't know. But the point is, this is really strong replication. This is the real stuff. Are all the results exactly like this? You just see things when the other one is looking at the picture. No, here are 2 other twins. You can get activity in the receiver, which you only see with synchronization before the image comes up and sometimes after the image has been, etc. And that's not surprising. And the effects are quite statistically robust. Okay, so what you can do is you can sort of say, what's the statistical significance of each of those peaks? There are altogether, there are 38 altogether, 26, 26? Yeah, 14 of those are statistically significant at various levels. Some are more significant than others because there are more electrodes. So what you can do is you can ask the question, what are the chances of getting that number of statistically significant effects in the brain and connectivity if there's nothing there, if it's just a fluke, if there's null? And the answer is the chance of that happening is about 1 in 500,000. In other words, that's extremely statistically significant. Okay, so the way that things are normally done with academic papers, you come up with a general statement like, we observe statistically significant functional connectivity changes in these isolated individuals only when the analysis is based on the image appearance time as viewed by the sender. And this is the first view of these functional connectivity changes in any laboratory anywhere in the world. The second one, once again, this is the usually obligatory thing. To the best of our knowledge, this is the first report of functional connectivity changes consistent with the existence of these anomalous interactions of telepathy between sensorily isolated individuals. Now, I'm not psychic, but I can guess what's going through a lot of your minds. This. All right, so what? And what I want to do now is just sort of pan back and look at the bigger picture. So what's the significance of this? Well, first of all, the studies of this kind produce evidence for consciousness-related phenomena that are not consistent with our current understanding of the laws of physics. Let me just make a brief comment here about quantum mechanics. A lot of researchers are very interested in integrating insights from quantum mechanics and consciousness. I mean, being a little bit unkind, quantum mechanics and entanglement, etc., is weird. Consciousness processes, that's also weird, but just putting two weird things together and hoping that one explains the other, I don't think necessarily gets us any further. I think quantum mechanics is a very powerful metaphor as a way of understanding what's happening. But quantum mechanics and physics is still a work in progress. And to be frank, I believe physics needs to expand significantly to be able to understand the sort of consciousness-related phenomena, if ever, that we know exist. Generally, we know that evidence not just from these types of experiments, from near-death studies, for example, but also the work of Ian Stevenson and children who remember past lives, which I think there's some very good work there, particularly by his successors, suggests that consciousness is not just is not only an irreducible component of the universe, but that consciousness can exist independently of the physical structure, such as the brain. So what am I suggesting? Well, it might seem that I'm suggesting, well, there's this thing called consciousness, and there's matter and energy, which includes the brain, for example, and they're completely different. Consciousness can exist independently of the brain, for example, etc. Now, the basic problem with that form of dualism is, well, if they're so completely different, how on earth can they talk to each other? How on earth can they interact? And the answer that I believe is, and many philosophers take this point, is that both consciousness and matter energy are in fact both manifestations of something much more fundamental. The analogy that I use is sometimes you've probably all played with electrostatics. You get a bit of plastic, rub it up against some wall or something or other, create an electrostatic charge, pick up pieces of paper, etc. That's electrostatics. You can get a magnet and it'll pick up pieces of iron, it'll point in the north direction, etc., etc. However, they look completely different, but they are in fact both manifestations of a deeper process called electromagnetism. They're one thing, but two manifestations of that one thing. I believe that consciousness and matter energy are both manifestations of something much more deeper and fundamental. And so my philosophical position would be one that's known as neutral monism, something more fundamental. Okay, what else can I say about the so what? Well, I believe that these sorts of studies will contribute to our understanding of how brain and consciousness are related. They're not the same thing. For most physicalist, materialist scientists, consciousness is just what the brain does. It's an end of story. No brain, no consciousness. And I think this is where parapsychology presents the hardest evidence to say, no, that view is incorrect and is limited. Now, there are two ways that you can sort of see what is the relationship between the brain and the mind. One is that the brain is a very sensitive antenna and transducer needed to pick up these really weak signals coming from the domain of consciousness. That's one view. The other view is no, the role of the brain is not so much a sensitive pickup, but it's a filter to reduce the input from this domain of consciousness. And this view of the brain acting as a filter to suppress psi influences isn't new. It was suggested by William James and Henry Bergson, William James being the father of American psychology. And I think there is a lot of merit to the notion that, in fact, were these filter systems not working, we would be overwhelmed with an enormous tidal wave of psychic perceptions, which I think would really compromise our ability to function at all. Now, does that mean that if certain brain networks play a major role as a filter to reduce these psi influences, does that mean that damage to these networks will increase psi capacity? Now, it's very interesting that David Morehouse mentions that it was that accident where a bullet hit his helmet while he was training in Jordan, which led him to start having a series of experiences which he hadn't had before. Now, this is actually very common. There's quite a bit of research suggesting that brain injury can increase what some people view as, oh, they're just hallucinations. But no, some of them are actually psychic perception. And there was a fascinating paper published in 2018 by Morris Friedman and his crew that looked at, are people who've suffered frontal brain damage more psychic? More particularly, can they influence a random number generator, sort of just by thinking about it? Can you move the cursor more? And now theoretically, the cursor should just stay in the middle because the random number generator produces a naught or a one randomly. A naught might make the needle move to the left and a one to the right. And essentially a quantum random number generator produces the same number of noughts and ones. And what you find is that normal people, so people who are not brain injured, have essentially very little effect on the quantum random number generator output. But this particular paper showed that people who particularly had left frontal brain damage, and also another one who had what's called frontotemporal dementia, these people actually produced statistically significant effects, whereas the normals, the people without brain injury, could not. And so that's just one example of brain injury actually enhancing psychic capacity. And in fact, I suspect that there are many cases. There's a famous one in the 1980s, a Dutch clairvoyant, Croiset, I think his name is, who claimed that he became clairvoyant when he fell off scaffolding, when he was doing some painting. And as I said, there are many examples like that. Peter Fenwick, a neurologist in the UK, starter of the Scientific and Medical Network, mentions that he would often see in the neurology clinic patients who'd experienced brain injury saying, I'm hearing other people's thoughts. And as I said, most people would say, well, you're just hallucinating. That's the effect of the brain damage. But in fact, it may have been that. Now, I'll skip past this one because the regions which do the inhibition are actually related to those that participate in the creative process, determining whether an idea is good enough in creativity. But I don't have time to talk about that now, so I'll just move on. So if the brain is primarily a filter, what this suggests is, first of all, studies of this type may in fact contribute to developing new approaches to expanding human capability, because if we could see what patterns of brain connectivity are associated with increased psychic perception, there's a technology known as neurotherapy or EEG biofeedback, where you can give feedback when those particular networks become activated more readily, so you can gain control over it. But the other thing is, it could well be that some psychiatric disorders may be a consequence of disturbed brain consciousness interaction. And these studies, and I'd like to think the studies that I'm engaged in, may well point to new and improved ways to treat these without the use of drugs. So what I've tried to do is step back and sort of say, okay, this is just the beginning. It's a specific study. I think it has broader implications. The field has broader implications. You know, one of the obvious ones is consciousness is more than just brain activity. There is a non-physical dimension to consciousness, and that's crucially important. One thing that this sort of study is not intended to do is to provide a piece of evidence that the skeptics will say, oh my God, yes, hallelujah, we all believe this stuff's real. Let me just tell you, as far as the so-called skeptics, David sort of touched on this as well, nothing in the way of evidence will change their mind. They're basically committed to a particular point of view, which has nothing to do with fact. It's all to do with their psychology. And for more to the point, they've locked themselves into a particular position. Essentially, they're the go-to person if a newspaper wants a comment from a skeptic. There's a famous comment that Max Planck, the famous physicist, made quite a while ago, which I think applies here. Science progresses one funeral at a time. And the basic idea is people tend to get locked into a particular viewpoint, and facts are the last thing that will change it. There's no point in trying to convince them, and I certainly have no intention of using these results, even though I think they're going to be robust, probably the most robust and replicable, certainly in this domain. And the implications, I think, are quite profound, because rather than just using this study to prove, hey, guess what, this stuff happens, I believe there's already more than enough evidence to say this stuff is real. There are a massive number of meta-analyses, which, as I said, if you're after facts, you know, you would have been convinced a long time ago. What I think these type of studies break new ground in is they actually look at, in a much more subtle way, what is happening in the brain associated with these. It gives us insights into brain functions, which are aspects of these experiences. So basically, it's looking at the domain of what's happening in the brain that is correlated with these things. I'm not saying it's all to do with just what the brain does, but that's clear. It does involve behavior. Sometimes people see things, feel things. So clearly something's happening in the brain, and we need to look into there. And also, as I said, it has these broader implications in terms of understanding human capacity and being able to develop it further, and also better ways of understanding and treating some so-called psychiatric disorders, which may in fact be related to treatable disorders of this filter process. So thank you very much for your attention. That's all I've got to say. I'm happy to take questions. And
Thank you so much, Richard. That's fascinating. So the brain and consciousness is not the same thing.
Yep.
And
I'll stop sharing now.
Yeah, we do have some questions. I'll just read them out. So can the electromagnetic energy of the brain ride or mirror the energetic field of matter that is around us, generated by the earth naturally? Like, can any similarity of energetic field, either genetically shared or inherited, of siblings, such as the twins in this study, explain how they can connect with each other through the energetic field of matter around us all?
Okay. Look, I'll answer that in two ways. First of all, the most obvious one is the communication due to some sort of electromagnetic interaction between the twins? And the interesting thing is that hypothesis that it's electromagnetic is the reason that the EEG was discovered. Hans Berger, the neurologist, in the 1920s was a medical officer in the German army on the Western Front in the First World War. And he was involved in an accident where a horse-drawn gun carriage almost ran him over, almost killed him. He was only mildly injured, but it was a very close thing. He was shipped to the field hospital immediately, and within about half an hour to an hour of him being admitted to the field hospital, which occurred very quickly, he received a telegram from his father in Berlin saying, "Hans, are you all right? Your sister had a dreadful feeling something had happened to you," at the very time of the accident. That got Hans Berger interested in, oh, this is telepathy. At the time, radio was just becoming introduced more widely. And he thought maybe radio is the sort of model of what's happening. Now with radio waves, how do you generate radio waves? Well, you need electricity. So that's what led him to look for electricity in the brain. Now, okay, is that electricity, are those electric fields the means by which communication occurs? The answer is pretty clear, no. We know that from, for example, putting people in shielded cages, for example, or deep underwater, and salt water, particularly, seawater, is a terrific filter of electromagnetic energy, and interactions still occur. So it's unlikely to be due to these interactions. Are the Earth's fields influencing the brain? The answer is yes. There are certain frequencies known as the Schumann resonances, around 7 hertz, 21 hertz, etc. Weak oscillations in the Earth's magnetic field and electric field, which influence not just the brain, but the body, and particularly the heart. So there's a lot of evidence, but it is unlikely that these are the means of communication. These fields may put people into a state where communication is more likely to occur, but they don't actually, if you will, serve as the means of communicating.
Great, thank you. James?
Hi, just
Thanks,
going to try to mute. Hi, Richard. I am psychic, and you're wrong. I didn't think so. What I found your speech fascinating, and I've actually, in my book, I wrote about that World War I example. I just wanted to make a comment, and that is the problem with trying to find psychic events occurring in a laboratory. Isn't it kind of where you kind of need a Holter monitor for people with arrhythmia kind of thing, because they only experience it at certain times, so you can try and capture it that way. And the other thing that I totally agree with you with the sender receiver, the sender has to have some kind of really emotional event, something traumatic. And again, I see that as being tricky for you to replicate in the lab.
Okay, look, thank you very much for that comment. Jane, you make a very good point. Generally, the experiences that these identical twins report, but also psychics, are ones that are really dramatic. Someone's died, someone's involved in an accident. Sort of really, generally they're unpleasant things. It doesn't happen that often that it's pleasant things, unfortunately. But there you are. Now, that's true. However, what I believe is that those are, if you will, the strongest experiences. I think we are actually in tune almost all the time, but at a much lower level, much more subtle, much smaller effects. And I think then it's related to what is the methodology you're using? Is it sensitive enough to look at much more subtle, weak and processes? Now, I believe that the functional connectivity methodology that we developed is much more sensitive than what you can get with EEG. I've worked with EEG for a long time. I know EEG, and it's much more sensitive than fMRI. So what I'm getting at is I think essentially what you're looking at when we sort of say, these things only occur at certain times, true. They're the ones that break through into consciousness. But I think for every, I'm guessing here, for every one that breaks through into consciousness, maybe 1,000 events which have a little ripple across the brain, which don't emerge into consciousness. And I suppose that's what we're trying to look at.
Thank you for taking my question. Joyce was wondering why I'm here out of the 40 people. It's bizarre that I got this email, but it turns out that I've been in touch with Jeremy Dean. I bet you know who he is. Rupert Sheldrake,
Yeah.
Joseph McMonagle, Russell Targ, Florence Garnett, Eric Robertson. I could go on.
Yeah.
Professor Kate Jeffrey. And what I've pitched them on is something related. I'm trying to get them to take on the research that I've found after the 2 years, that the block between your conscious and subconscious mind is related to telepathy. And you were talking about that exact thing, because if there was no block, you couldn't function. Your subconscious mind has every experience. And so I'll make this as fast as possible. I realize because there's research that says your brain changes after you're 6 years old. Do you agree with that?
Well,
that most of the development of your brain happens before you're 6.
Yeah, although it's plastic and it tends to change, but less so as you get on. I'd like to think mine still has the capacity to change.
Okay, so the investigation and research that I had showed that I have a connection with my daughter, and subconsciously she can go hide, and subconsciously she can tell my subconscious mind, but it can't tell me, but it can tell my dog. And my dog has found her hiding in a mall, which is impossible by scent. I paid the Canine Institute to analyze the video and verify there was no scent involved. And then what I did was I realized that it's after you're 6 years old. I found a little girl who's 5 years old who found her parents hiding. And if you watch the video, it's obvious it's telepathy.
Yeah. There's the interesting thing is that 5 or 6 year period is an interesting one, because there are some drastic changes that do occur. One is there's a phenomenon known as neonatal amnesia from about the age of 3 up to about 5 roughly. It's as if a curtain comes down and it's hard to remember what happened before then, even though your memory was working, like at the age of 2, for example, 2.5, 3. Now, the interesting thing is that children who remember past lives, who claim to remember past lives, the interesting thing is that frequently stops or fades from about the age of 5, 6 to about 8 or 9. Not all, but frequently it drops away. And I gave a talk a while ago about what I thought was the neural mechanism which sort of brought the curtain down, but that's a separate issue.
You mentioned past lives. I don't mean to, about the Laura Buxton story. The twins, they're not twins. The little girl that sent a balloon up in the air and it came down 150 miles away.
Yes, I remember that one. Yeah.
You know that story. To me, that implies we're living in a simulation. That's a glitch in the simulation. What do you think?
All right. Okay. There's the notion that we're living in a simulation, of some super advanced civilization in the future, and we're all just part of a simulation of some teenager in his garage, sort of putting this together. Look, it's philosophically, people like to discuss and speculate that. I wrote a very, very short paper on what are the energy implications of simulating just 1 cubic meter of matter to the resolution that these people claim is a simulation. And what it turns out is, just because of the link between information and energy, just being able to simulate 1 cubic meter of matter, down to the level of, let's say, proton or quark level, implies that you need to turn the equivalent of 100 sums in matter into energy per second. So what I'm getting at is that the philosophy is fun to speculate, but if you try to turn that philosophy into physics, you end up with very, very strange answers. But more generally, I think our view of the universe is extraordinarily limited. The universe, I think, is far stranger and weirder than we could possibly imagine. At a fundamental level, whether it's a simulation or a hologram or whatever, I'm not really too concerned. But certainly, the reality is the more fundamental, deeper reality is much, much different. I'm thinking of writing something about that, but it's at this stage, I think that's all I can sort of say. Thanks.
Yeah,
Thank you, and I'll let somebody else talk now. Go
Yeah,
ahead.
thank you. Yeah, Vlad.
Thank you for the presentation. Absolutely amazing. I guess two questions. One is just a curiosity. That one was to do with when you got the coherence. What brainwaves are we talking about in terms of frequency?
Okay. The method doesn't use just the ongoing EEG. We have those strange goggles that you saw people wearing. They produce a flicker, which is there the whole time, exactly at 13 cycles per second. And there's a reason for 13 cycles per second. And what we're looking at is the brain's response, because the brain responds to every sensory stimulus. And the brain produces a very small oscillation in many parts of the brain, not just the visual cortex, at 13 cycles per second. And what we're looking at is the coherence or the connectivity at that 13. In other words, if they're exactly synchronized, they're talking. And if they lose synchronization, they're not talking to each other.
Okay, all right. That's
I'm happy to send you some papers on that.
The other question is a bit more theoretical. So you found that certain regions of the brain will become more coherent and decoherent and so on. And then you also mentioned neurofeedback.
Yes.
So there is a potential here to perhaps find the locations and actually train individuals to become more receptive.
Look, that's what I was suggesting when I talked about enhancing human potential, for example. That it does open it. The other thing is the networks that are actually activated tell us something what's going on. For example, the most common area that gets activated when looking overall is the temporal cortex, which suggests memory processes are being triggered, even though there's no conscious access to those memories. It's memory processes that are being triggered in what I'm calling the receiver when the sender's looking at things. So the functional connectivity can actually tell us what's going on. And the other point to note is there are big differences between individuals. It's certainly not one size fits all or just one thing. It varies, but I think each individual has a particular signature. And it could well be that if we can identify that signature, then you could use, as I said, like EEG neurofeedback type training to enhance that, assuming you wanted to do that.
Yep.
Okay.
Which parts of the brain would be the best candidates for the neurofeedback, do you think?
Look, I'm guessing here, but I suspect temporal cortex, memory related, hippocampal area is the main one I'd be looking at.
Okay.
Yeah.
All right. Beautiful. Thank you.
Lance.
Yes, thanks, Richard. Excellent talk. Just going back to some of your earlier slides, was that one pair that produced effects for the general pictures, but not the personal pictures?
Yeah. And then on the repetition, it flipped.
Switch.
And they responded more to the personal images.
Okay. So that never happened with any other pair.
I'm trying to.
I think it was slide 11 or 12.
Yeah, no, that's right. No, I don't think it did happen with others. Look, I really cut back just to some of the key ones to illustrate that. No, I did. Look, there was so much variation between individuals. At this stage, I'm a little bit reluctant to generalize and sort of say this is what happens generally. I'd like to sort of get more data and then sort of look at essentially what the pattern of the responses is, etc.
I would expect that the emotional factor was the more salient. You've demonstrated that, but the novelty aspect, if you're familiar with Walter von Lukadow's work, in a closed system, novelty is a key factor because it gets the individuals motivated and enthusiastic. But that can fall off, and when that falls off, you lose the effect as well.
Yeah, well,
So you probably just had a unique case, and you probably would be hard pressed to demonstrate that again, unless your participants were, were affected by novelty more than emotional engagement.
well, look, as I said, that was our speculation. That could just be a speculation as to why we got that particular pattern, because I don't think we saw that specific one in others, to be frank. It was either both personal or both, or in some cases, that you got the result in one session, but not in another session, for example.
Right.
So at this stage, the numbers are still small. I mean, we're only talking about 10 people. So it's much too early.
I think it's that they're very good results for such a small sample. That's a very good indication that you're on the right track and it's a good design.
Thank you. I like to think so.
Yeah, I don't know whether I missed this in your talk, but I was wondering about the actual physical collection mechanism. Did you, excuse me, did you have some sort of like thing on top of their head,
we had it looked like a shower cap. I didn't describe that, so you didn't miss it. I tried to sort of tone it down on the technology side, but basically it looks like a shower cap, and there are 20 electrodes located there. And basically what we're doing is we're picking up the brain's electrical activity, which is the EEG itself, and buried in the EEG is this 13 hertz signal as well. And what the signal processing does is just pulls out the 13 hertz part and then looks at, okay, how is the 13 hertz in this part of the brain correlated with the 13 hertz in this part of the brain?
Yeah, I thought that was really brilliant. That that. Now, do you have to go under the skin?
No. It's all no. Do you think we'd get any subjects if we had?
I don't know. I saw some YouTube thing where they were drilling, into the brain. So
yeah, there's some crazy stuff, but no. This is just standard EEG pickup, and I think our methodology is exquisitely more sensitive than many, which is why I think we're seeing such relatively robust effects with such small numbers. It is atypical in the area, as I said, but it goes beyond just trying to demonstrate, hey, guess what? This stuff really happens. I think the evidence is in there. We know that. Now I want to go further and say, what's actually happening in the brain? What can it tell us? And how can we use this information for betterment?
Okay, great. Thank you very much.
Thank you, Don. Just one more question before we break. So you just spoke about the memory part of the brain being emphasized in communication.
Yeah.
The area is also active with those who have mediumship skills too. Is there a reason why this area would be active in different skill development?
Look, I don't have anything more than a speculation. I think, to be frank, a lot of telepathy and even remote viewing, etc., all draws on memory process. In other words, I think it draws on images and content we've already got, but puts them together in new ways. For example, there were psychics in the medieval period, for example. But did they ever talk about Saturn's rings, for example, or the galaxy or black holes? No, they didn't. They described everything in the context of the sorts of memory content and experiences that they were exposed to. So in a funny sort of way, sort of scientific discovery creates content in memory, which can then serve as a basis for non-physical perceptions as well. Anyway, look, I'm probably speculating over the top of my head here, so stop.
Oh, that's great. Thank you so much, Richard. I found that really interesting and fascinating, and very much a part of the smorgasbord, not just the veggies.
Have your vegetables. Have your vegetables.
But yeah, we all really need more studies, using the scientific methods